This is the first example of section 7.3 day 2, and we're going to take the system that we were working on yesterday. We finished up with this one in the last example, and we found that z was equal to -3, and then we did back substitution to find the other solutions. We're going to do it a slightly different way today, even though we're going to get the same answer. We're going to get our solution through what's called reduced row echelon form of a matrix. Now, again, it's not going to be a different answer, it's just going to be a different way to get there by using matrices, and this can be helpful if you were solving systems mainly by a computer method of some sort. But here's what we did yesterday. We eliminated, for starters, the two bottom x values, and then we eliminated the bottom y value. And I told you, you really need to go in that direction in order to be successful. Now, in order to make this a little bit simpler today, we're going to get into reduced row echelon form, which is now, instead of just having zeros down here, it's also getting zeros up here. We're actually going to go in the opposite order. Now we're going to get rid of those two z's, the two upper z's first, and then the upper y, and that's basically so that we don't reintroduce any new variables here. So let's get rid of these two z's. Now what I'm going to do is I'm going to work backwards with this third equation, because if I multiply this by 2, I could eliminate the -2. So that's one thing that I'm going to be doing here, is I'm going to be taking this equation and I'm going to multiply it by -2 so that I can eliminate the 2 I'm going to multiply this by 2 so that I can eliminate the -2 in the second row. So I'm going to go 0, 0, 2, -6. That's my third row. And then the second row is still going to be 0, 1, -2, 8. If I add those together, I get 0, 1, 0, and 2. Notice that I still have the y value in here. I just got rid of the z and made that a new row. So that's, from the row operations we're doing, that's this first one here. That is 2 times row 3 plus row 2 is going to equal the new row 2. So this will be our new row 2 in the next matrix. I'm going to do a similar thing with the other one. Just do both of these at the same time so that we can not have to rewrite the steps so many times. Now I'm going to take this and I'm also going to eliminate the -3 from the first row. So I'm going to do 3 times row 3 plus row 1 is a new row 1. So, all right, that means I'm going to take this one down here, multiply it by 3, so that's 0, 0, 1, 3, -9, and then I'm going to add that to this row up here, and so that will look like the same as it is up there already. 1, 2, -3, and 12. Put those two together and we will get 1, 2, 0, and 3. So that's going to be our new row 1. So we're replacing row 2 and row 1 so that we can get rid of these two, and so that means that our new matrix is going to look like that. Alright, so now that I have all of these taken care of, these x's, or the z's, then I'm going to get rid of one more, and that's this one right here. I want to get rid of that 2 so that I can have all zeros except for the ones going down the diagonal. That's what it's going to take to give us reduced row echelon form. So let's take this one and see what we have. Now we need to get rid of the 2 so we can multiply this one by -2 and then add it to row 1. So that's what our row operation will look like here. Alright, so that being the case, we'll go 0, -2, 0, -4. Multiply that whole row by -2. And then we'll add that to this row. 1, 2, 0, 3. Put those together. 1, 0, 0, and -1. Alright, we're replacing row 1. So here's our new and actually final matrix on this one, because now we're going to be able to just take this as the solution to the original system of equations. Notice that in this first row we have an x, we don't have y or z, and then we have what it's equal to. So this first row really just means x equals -1. This second row, all we have is a y, so that row means y equals 2. And then this row only has a z, so that means z equals -3. So like last time, same answer, -1, 2, -3 is our ordered triple for x, y, z, but we just got it in a little bit different way.